computer. So guys, the area of this square is t times t. Is there another way to say that? Who's got a different way to say that? Tegan?
Height times width.
Ooh, I like it, but t times t is kind of even a better length times width, but there's another way to say it, and it's a really special way. How about you, Hannah?
I'm not sure. The one I had was t times t or x times t.
Well, it would be x times x. Like
Yeah, that's what I meant.
X times x. But what is x times x? I think you're going to laugh when I tell you. When you take a number, a, and you multiply it by yourself, by itself, guess what you get?
A squared?
It's called a squared. It literally is called a squared, and you put a little exponent of 2. That's what a times a is. And that's the area. Now, sorry for the noise. There's a sailing race going on behind me right now, and they're blowing a whistle. I thought you'd find it interesting to see that. Anyway, I have a challenge question for you. How many squares are on a chessboard? And I also want to remind you, it is way more than 64. So you can't answer 64 because there's a lot more going on here. So who can tell me why there are more than 64 squares on a chessboard? Omer, and then Tessa.
Because you can have like a 3x3 square and a 5x5 square.
Wait a minute, guys, check this out. I've got a 3x3. I've got a 5x5. Omer, that was awesome. Tessa, what do you think?
There's actually like a lot, and that's because it's not just like the 64 plus all of these, because the smaller ones can fit multiple times on the board, so you have to count all of the times that the smaller squares can fit on the chessboard, so it's like way more than 64.
Wow. And Adalia? Adalia, you want to add to that, honey?
The other ones, if you can also split each square into a lot more squares, and so then there would be even more.
Wait a minute. Can you explain that for me, please? I like what you just said.
If you split each square in half and then do a line in the center from the top to the bottom, then there are 4 more squares.
Whoa.
And then you can split those in half.
Yeah, I mean, and do you guys remember, if you were with me last year, do you remember what that's called when you keep doing the self-similar till infinity? Do you remember what that's called?
Doing it forever?
Yeah, but it's called a fractal. It's called a fractal.
I remember that.
So you would be able to keep multiplying and multiplying and multiplying. Adalia, that was a beautiful thought. But I'm going to tell you that I'm giving you a restriction on this question, is that you have to use a chessboard, and you can only use the dimensions, like Omer said, 1 by 1, 2 by 2. So let me ask you this question. How many 1 by 1s are there?
64, I think.
64.
Yeah.
And one thing that we did not do here A very, very bad mathematician would do what I'm doing right now. They would look at a square that is an 8 by 8, and they need to write 8 by 8. So if you guys have page 1 in front of you, you need to write 8 by 8, because I made a big mistake when I did not write the dimensions of that square. Now, go to page 7, please, and record 64 by the 1 by 1 size. So there are 64 1 by 1s. Now, instead of looking at the 2 by 2s, because that's hard, how many 8 by 8s are there?
1.
One.
Now, I'm going to record that, but why do I need to be careful where I put the 1?
Because if you put the 1 in the wrong spot, then it could make a big noise.
Well, what if I put the 1 over here?
It might
Oh,
look
when you add up the squares, it like multiplies it by.
Looks like it's a 10.
Yeah, it looks like it's a 10. So then you have to put it.
So don't line up your 1 with the 10s column. Line your 1 up with the 1s column. And now, can you guys make a conjecture? Don't say it out loud. How many 7 by 7s do you think there are on a chessboard? Don't say it out loud. I want you to think about it. And I think I got a chat from somebody, which is great. But I don't. Ah, nice. So I got 2 chats. One of them is correct. I don't know. I got a third one. Nope. So Adalia, I agree. I don't agree with the other ones. Now, guys, can you guys watch me move the 7 by 7? Are you ready? Count with me. Go. 1,
1,
Oh,
2, 3,
4.
4.
and that's it. There are only 4 7 by 7s. Now, do not say it out loud. Can you make a conjecture about how many 6 by 6s? Send me a quick chat about your conjecture. And if you have a conjecture, it's so much better to hear why. Like, what's the reason why you think it's like, I don't know, 10 or 5 or whatever you think it is. So I'm looking at the chats right now. Hannah and Omer, you're really close. And Adalia, I'm not sure I understand the answer, but I'm going to look at this. Oh, interesting. So I got Tessa, Adalia, Omer, and Hannah, and I do not agree with anyone. Isabella, still don't agree. We're looking at the 6 by 6s.
Oh.
Now, are you guys ready? Take a journey with me. Go. Say 1,
1, 2,
Oh, I counted wrong.
3.
and then now go down. 1, 2,
2,
3. So come on. What is 3 by 3?
9.
9.
9. There are 9 6 by 6s. And now I want you to make a conjecture about the 5 by 5s. Don't say it out loud. Send me the chat. I now created a 5 by 5 for you. And Tessa, I'm not in agreement yet. You guys have to think.
Wait, I think, no, I actually do. Oh, I forgot to count the first one. So,
Yep, so Hannah got that last one, good. Ah, Adalia and Tessa got it. Very nice. Guys, count with me. You ready? Go. Go. Hannah, not exactly. Let's do it, guys. Ready? 1,
1,
2,
2,
3,
3,
4,
4,
by
5,
1,
6,
3.
7.
No. It's a 4 by 4. 4 times 4. Tegan, Isabella got it. 4 times 4 is what, everybody?
16.
Guys, do we even have to put the next one on the screen?
Wait, but what if you move it to the right?
Wait a minute. Ask that question again, please.
What if you move it to the right?
1, 2, 3, 4 times 1, 2, 3, 4. Whatever you do, it's going to be 4, 8, 12, and then 16. It's a 4 by 4. What do you think the next array is going to be, guys?
20.
25.
25, of course, because that's going to be 5 times 5. And then the next one is?
36,
36.
And the next one is?
36.
49.
No,
now,
49.
I want everybody to add those numbers and to send me a chat. That's going to be the total numbers.
What did you do? Yeah, what? I mean, what is it? Right next to it. It's right there. Don't be rude.
So I'm looking for the total.
19. 20.
David.
And guys, I strongly, well, I'll show you my method in just a minute.
Yeah.
Oh, Hannah's got it. Very, very nice. Tessa, I think you have a place value issue.
Oh, right. Yeah.
Natalia, I'm not sure where these numbers are coming from.
I messed up in the beginning.
Okay. So Tessa, I still don't agree. Can everybody please just watch me
There's
navigate?
1 plus 9, and then 4 plus 16, and
Do you guys know what it means to navigate? It means, it's a boat terminology, but you're gonna watch me solve this, and I wanna show you how simplistic I make this, because I like to make math easy for me. Okay, you guys ready?
Wait, do you do the thing where you match up all the numbers that add up to 10 and then you?
Who said that? Tessa?
Yeah.
Oh, Tessa, you're awesome. Now, guys, come on, give me a 10.
Yeah.
1,
4,
6
14,
is
4,
10.
9 and
6,
1.
6 and 4 is 10.
9
Keep
and
going.
1.
1.
9 and 1.
9 and 1 is 10. Go.
And then 9 is 5 and 5 is 14, but that's the last. Oh.
And guys, don't we have 10, 10, 10, and 14? What is that?
44.
44.
And guys, we have to regroup 4 in the 10s. Now, guys, 4 and 6 is 10, and 4, 3, 2, and 1 also make 10. 2 10s makes what?
20.
20.
And 20 tens plus 4 ones is 204. Now, I know that a lot of you try to do these one at a time. So for instance, you might do 64 and 49, and you might write down 113. Then you would do it 113 plus 36 is 140. And then that plus 25. Guys, is this method an efficient method?
No, but it worked.
No, it'll work, but it is very, very inefficient. So that's why, but then you would have to add 9 and 4 and 1, and that would give you 204. But I do not like this method only because it takes too long. And only one of you got the right answer. Only one. And I can guarantee you that if you do it my way, you'll always get it right. Now, what if I said to you, how many squares are there in a 10 by 10 board?
Lots.
What do we have to add to 204, guys?
Isn't it like 20 more? Or like, oh yeah, isn't it like 204 times 4? No,
Nope,
times
nope.
2.
No. Come on, I want you to think about it, guys.
A fourth of 204 plus 204.
Oh, so you basically wanted to do 5/4 of that. And Adalia, I'm gonna say, I don't know. Maybe, but guys, aren't we missing the 9 times 9 and the 10 times 10? Guys, here we have all the squares up to 8 squared. 1, 4, 9, 16, 25, 36, 49, 64. We need 2 more squares. What are those 2 squares? Come on, what are those 2 squares?
Um,
Come on, what's 10 times 10?
100.
100
And
and
what is 9 times 9? 81. Add
81.
them together, come on. 4 plus 1 is,
305.
now, are you ready for the next challenge?
probably.
What about a 100 by 100? Now,
Mm.
now Omer's going,
Just
Kramer,
multiply
there's
3,
no way.
5. You just
Now, would you guys like to see something very cool?
couldn't
ready?
you just multiply the 385 by 10?
You can multiply it by 10, but that's going to give you a very small number compared to the answer, I believe.
Hmm,
Now, would you like to see a formula? This
maybe.
is an algebraic formula. Everybody write this down. So I want you to write down f of n. So f of n is like an italicized f, a parentheses with an n in it. And then I want you to make a long fraction. And that fraction is going to have a denominator of 6. Omer, I don't see you writing this down. And I'm really all about the pen is the gateway to the mind. Without the pen, I am nothing. Actually, without my glasses, I can't see. So if I had no glasses and no pen, I would be like, I don't know, like a bird or a dog or some animal. Okay, you guys ready? On the top, in the numerator, n times the quantity of n plus 1 times the quantity of 2n plus 1. Now, if you don't understand what that means, that's okay, because I really haven't explained it yet. So I want you to just write it down. Now we're going to have some fun. We're going to use something we already know the answer to. We know that when you have an 8x8 chessboard, we know that the answer is going to be 204. Can I ask everybody to substitute, wherever you see an N, I want you to substitute an 8. So the way it should read is 8 times, well, what's 8 plus 1? Come on, what's 8 plus 1?
9.
It's
Nine.
9. And what is 8 times 2 plus 1?
17.
17.
Okay, divided by 6. Now, my question to you is this. Should we immediately multiply across 8 times 9 times 17 and then divide by 6? Or do you have a more efficient method? And if you have a more efficient method, please raise your hand electronically, because there's something really, really important here. In fact, it's really a math rule. Before you across multiply, that is numerators times numerators, denominators times denominators, what do you always have to do? Does anybody know? Isabella. Go, Isabella. And Isabella, I do not hear you. So maybe you're in parentheses. Oh, yeah. There you go. Isabella, you can share now.
Well, for the multiplication thing, you could do 8 times 2 times 9 times plus 9 times 2 plus 17 times 2.
Yeah, but where are you getting those from?
I'm dividing 6 by 3 because there's 3 numbers you have to times by.
Well, guys, the word is cross simplify or cross cancel. You guys have to look at 9 and 6. And just like Isabella said, how many times does 3 go into 9? Go. Come on, say it out
3.
loud. Everybody's muted. You're all
3.
muted. Everybody unmute yourself.
3.
It is 3. And how many times does 3 go into 6?
2.
2.
Now, can we also cross cancel 8 and 2? Come on. 8 and 2 become what? 2 goes into 8 how many times?
4.
4.
And 2 goes into 2.
1 time.
And now all you guys have to do is 4 times 3 times 17. It's so much easier. And when I do this, I would do 17 times 3 first, and then I would multiply that by 4. 12 times 17 is a little bit harder. So what is 17 times 3? Say it out loud.
51.
And what is 51 times 4?
202. 4.
Oh, has to end in a 4. It is
204.
104. So guys, it works. Now, do you remember when we did the 10 and we got 385? Can you show me that our formula works for 10? Go ahead and do it, guys. N times n plus 1 times 2n plus 1, all divided by 6. So f of 10 is 10 times 11 times 21 divided by 6. And you better cross cancel. Do not multiply 10 times 11 times 21 and then divide by 6. It takes too long. Who can tell me what we can do with cross canceling here with 6? Does anybody have an idea?
This goes into 21. I haven't figured out how many times.
Well, it's not 6, but what goes into 21 and 6?
3.
Yes. And so 3 goes into 21 how many times?
7.
2.
And 3 goes into 6.
2.
Twice.
And then we can cross cancel 10 and 2 to become what?
5.
5.
I mean,
Yep.
1.
5 and 1. All you have to do now is multiply 5 times 11 times 7.
What about 1?
It's 5 times 11 times 7. Which do you think you should do first?
7 times 11.
77 times 5. That's pretty easy. What about 35 times 11? Do you guys see how I multiply by 11? I add 35 to itself, but I push it over one place value. And what do you get?
35.
185.
All right. Now, was that the correct number?
Yes.
Now I want you to do f of 100. You have a 100 by 100 square. Here's your formula. F of n. And what I want you to do right now is I want you to ask a good question. If you want to understand better what's going on and you don't, this is the time to ask a question. Raise your hand electronically and say, Kramer, I'm really not sure what to do first.
Why does this work?
Well, because when you take a square and you add it to the next square and to the next square and to the next square, it creates a recursive formula. And I will show you later on in the year how we can develop our own formulas. They're really, really cool. I love algebra because there's no way I'm going to add 1 plus 4 plus 9 plus 16 all the way to 10,000. There's no way I'm going to do that. With algebra, you don't have to. So you can send me a chat with your answer. And Tegan, question. Tegan?
How many times do I have to multiply? So for the n, does that mean multiply 100 by 2 and then add the 1?
Absolutely.
The 2
And Tegan, when you do 100 times 2 plus 1, what do you get?
100 times 2 plus 1. 201.
Exactly. Now, the real difficult part here, and Tessa, I can't see you anymore or hear you. What the really hard part is knowing how to cross cancel. Like the first thing I see, guys, and Cameron, should I do 106? And what should I write down above the 100? And what should I write down below the 6?
100 would be 50, and then 6 would be 3.
Wow. Nice work. And then Isabella, do you have any more I could do here?
Well, that's how far I got so far.
Does anybody see that 201 is divisible by 3? Who can tell me how I figured that out without dividing? How did I
Because
know that 201 was divisible by 3? How did I know that?
Because 2 plus 0 plus 1 equals 3, and then 3 is divisible by 3.
Was that Adalia?
Yeah.
Honey, that is awesome. Guys, did you listen to what she just said? All you have to do is add the digits. And if it adds to a multiple of 3, then it is a multiple of 3. And so therefore 3 goes into 26 times with a remainder of 2. 3 goes into 21 7 times. And ladies and gentlemen, that is 67 and 1. Now, all you have to do now is 50 times 101 times 67. And that's going to be your answer. Now, if anybody has any strategies, I would love to hear it. Does anybody want to share? And you could even ask a question. You don't have to have a good strategy. You can just ask a good question. How about you, John? Or Alexander, I'd love to hear from you. And I'd love to see your video too, Alexander.
Sorry, I was just picking up some papers from the floor.
Okay, no problem. Good to see you. Now, how are you going to multiply these? What are you going to multiply first? Omer, what do you think? Cameron, what do you think? So Adalia, what would you do first?
50 times 101.
I think that's okay, but those are the easiest. I always like to multiply the hardest ones first. But that's a good, why don't you try that? Hannah?
Well, I would start with 50 and 67 because it's easier to multiply things by 101.
Exactly. So when I do 67 times 50, guys, I just do 67 times 5, which is half of 670. You guys understand that? I multiply by 10, I cut it in half, I get 335, but don't forget, it's not 5, it's 50. So 3350. Now I have to do 3350 by 101. And Adalia, I want you to see how simple and beautiful this is. Did everybody write this down?
No.
Please write it down. Now, 1 times 3350 is what? Say it out loud.
3350.
3350.
And now you don't need to do the zeros. It's a waste of time. But you have to create 2 place value holders. And then do 1 times that number again. And what do you get? 3350. Now all you have to do is add. And what do you get, guys? Come on, we can even do this from left to right. We normally can't, but there are no carries. Go.
3, 8, 3,
5.
0.
And now I give you the number of squares in a 100 by 100 square. 338,350. Now that it totally blows me away to think about how long this would take us if we did not have the formula. Do you think it would take literally forever to do? I'm guessing that it would take me about 10 hours to do that problem, but we did it in less than 10 minutes. Now,
The patience for that.
yeah, I have no patience for the 10-hour deal, but man, do I love algebra. So I'm going to give you guys now f of 20. And the question is, do you need me to write down the formula, or do you guys have it?
I know.
Do you need me to write down the formula? Yes or no?
I don't think so.
Okay.
You could write it.
I'm going to see what you guys come up with. And I'm going to call this the Cameron approach, because what he did last time I really liked is he cut 20 and 6 or 106 in half. I'm going to cut 20 and 6 in half. And then I have 21 and 3.
I think I finished.
Yes, send me a chat, please, with the answer. I do not agree. Guys, and Adalia, look at the 10 times 7 times 41. I see 70,
Oh, I know what I did.
41. Hannah, you nailed it. So Adalia, 4 times 7. And I don't agree, Isabella. Isabella, how did you arrive at that?
Actually, I messed up.
Okay. And so Adalia, you got to look at these numbers. You got 41 times 70 is 7 times 41, tack on a 0.
First time I did 6 times 41, and then I just added 41 to the answer I had before.
Ah, interesting. So guys, the answer to this one was 2870. Because
I just thought that.
good. 10 times 7 times 41. Now, I got a little challenge for you. And I'm going to tell you which page to go to. Hold on. I want you to go to page 18, please.
Oh dear.
And so when I was your age, Mr. Cunningham, hey guys, try not to drop the dishes. Mr. Cunningham, my math teacher, said, Kramer, I want you to memorize the first 25 squares. And I said, Mr. Cunningham, you know, I really don't like memorizing lists of numbers. And he goes, Kramer, make a game out of it. This is, you know how tall Mr. Cunningham was? He was like 6'5", and I was like 2 inches tall. So, I mean, he was like a towering figure. And he goes, make a game. So guess what I came up with? A stopwatch. So I want everybody, if you have a stopwatch, and my stopwatch is my cell phone, okay? And I'm gonna go to a different page so I can't see it. Are you guys ready? I'm gonna do the first 25 squares. Let's see how fast I can do it. And then you guys are gonna play this game too. Ready, set, go. So let's do 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, 400, 441, 484, 529, 576, 625. 32 seconds. Now, what is my job? What is the challenge for me to do the first 25 squares? What do I want to do against my other time? Anybody can share. And you guys should unmute yourself. Omer, Alexander, Tegan, and Adalia. Unmute yourself. Okay, so
Okay.
what is my next step? What's the next round of this game?
Try to get better than 32.50 seconds.
Yes. My job is to do it faster and faster and faster. So I want you guys to consider memorizing these, but using a stopwatch to create a time. So it goes really, really fast. Now, what happens if you hit a snag? So for instance, let's say I'm having trouble with 18 squared. My advice to you is write out 18 times 20 minus 2. Do you agree that 20 minus 2 is also 18? Is that a yes?
Yes.
Okay, do you agree that 18 times 20 is 360? Do you agree?
Yes.
Yeah.
And what if I subtract 2 18s?
32.
So if you subtract 36 from 360, do you not get 324? Yes?
Yep.
Okay.
Well, yes would mean you don't.
Say again, please.
The way you phrased it, yes would mean that you don't.
Okay. So my apologies for phraseology. Can you guys do 17 squared using the same method right now? And you can do it if you want by just 10 and 7. And you can send me a chat with your answer. Good try, Isabella, but you gotta try again because Isabella, this is 170. 17 times 10 is 170 all by itself. Now you gotta do 17 times 7, which is 70 and 49. Hannah's got it. Does anybody have any questions about my distributed property method? This is the time to ask a question. If you're not a master of this yet, and Cameron, you got close, and
What do we
Alexander,
have?
do you have a question?
No.
So what was right? I mean, help me out.
So I got 17 times 10 is obviously 170. Then you do, don't you do 17 times 7?
Yes, which is 7 times 10 plus 7 times 7,
Yeah,
which is 70 and 49,
yeah.
and that is
Wait.
89.
I
And guys, watch me do 19. When I do 19, I'm not doing 10 and 9. I'm doing 20 and 1 because it's easier. And I get 380 minus 119, and that gives me 361.
That's not 119.
No, what I meant to say was 1 number 19.
Oh, I was
So-
like, wait, what? You're like 119? And I'm like, no, that can't be possible.
Right, so that's 119. If I were doing, I don't know, 16, I would do 160 plus 96. So I want you guys to practice this week. Practice your distributive property. Practice your first 25 squares. Practice finding patterns in these amazing numbers. And if you have any questions, don't wait 167 hours to ask it. Send me an email through your parents, and I can help you if you're having trouble with this distributive property. All right? You guys were amazing. I love being back and wish we were face to face, but doesn't look like that's going to happen for a while. And I wish you a beautiful night. Would you guys like to see the sunset?
Okay.
It already is here.
Well, the sunset here
am here.
is pretty spectacular. You guys like that?
Yeah.
Whoa.
Wow. That is
Yeah.
nice.
Ours is right there.
And that's what I see every night. So, and that's why I live on the water. Anyway, I'll see you guys soon. Think of great questions, work your distributive property, and work that muscle. Okay, guys, have a great
What's
night.
the
I'll see you in
penny?
167.
Bye.
Bye.
Great to see you guys.